Going to get started on the next chapter. Let's see. Anybody here use Dropbox?
Yes.
It's pretty cool. Pretty cool. Okay. So this section is about quadratic functions and models. So can anybody tell me what a quadratic is? Yeah.
It's the x squared plus 2b, or there's like this.
Yeah, that'll work. It's got an x squared in it. That's the highest power. So it's got to have an x squared in it. It can't have an x cubed, but it's got to have at least an x squared. It doesn't need an x term, it doesn't need a constant term. It's basically a parabola. Okay, so you've studied parabolas before, but we're going to look at them a little bit differently. Okay, we're going to review some of the stuff that you already know how to do, but we're going to jump right into vertex form and completing the square and all that sort of stuff. Okay, and then in this section, we're also going to learn how to use those to solve more complicated problems than you did in 1010. Okay, so when we graph a line, we usually put it in a graph-friendly form that looks like this. Okay, what do we call that again? Slope-intercept. And it's a really nice, easy form because you can look at it, you can tell where it crosses the y-axis. Everybody knows where the y-axis is, so all we need to know is where it crosses, and then the m tells us what the slope is. Okay, so that makes it nice and easy. Okay, when we need to graph a quadratic function, or in other words, if we graph this shape, if we graph a parabola, we also put it in a graph-friendly form. And that graph-friendly form is like this. And we talked about this before when we did transformations and everything. We can look at this and we can tell where the vertex is, and we can tell whether it opens up or down based on what this number is right here. Okay, does anybody remember what we call this? I just said it a minute ago. Okay, it's called a parabola, but what form is this? No. There we go. Okay, this is called vertex form. How you doing? I thought you were going to be Samantha. She was coming in late because she got her breakfast and she was railing about the J-Tech kids. Is that right? Nice. Looks like you made out okay. Okay, so we're going to put these in vertex form, and that's a nice graph-friendly form, but the problem is they don't always come in that form. If it always came in this form, it would be really easy. We could look at it, we could tell what the vertex is, we could tell whether it opens up or down. Based on what this number is, we could tell whether it's been stretched or shrunk and all that nice stuff. Most of the time, they look like this. And if it looks like that, there's not a whole lot that you can tell about the shape of the parabola and where it is. Okay, so we have to put it in vertex form in order to be able to graph it. Okay, so this is just a review. You would have seen this stuff in 1010. So we're going to talk about how we can take something that looks like this, or here's our first example right here, and how we can put it in vertex form. And we do that by completing the square. So here's the process. We move the constant to the end and put parentheses around the first two terms, leaving room in the parentheses for the new constant. So let's go ahead and do that on this guy right here. So this is what we're going to do. I'll go ahead and write f of x. I'm going to write 2x squared plus 8x plus 5. Okay. Now a lot of people put parentheses on it right now. You don't have to, but it might not be a bad idea. We're now on step number 2. And in reality, we're going to end up, once you get some practice, we're going to do steps 1 and 2 together. Okay? So I just did step number 1. Here's step number 2. Step number 2 is to factor this leading coefficient out. So we need to take a 2 out. Just out of the things in parentheses, we don't worry about that 5 for the time being. So we're going to write 2 parentheses x squared plus, what does this become? It becomes a 4x. Okay, I leave room in the parentheses to complete the square, and I've got this plus 5 sitting out there. Okay, now everybody stop for just a second. I realize if some of you might already know how to do this. Okay, I just want to make a point. Have we changed anything at this point? No, we've just changed the way it looks, right? We've just rearranged some stuff. Now we're going to start changing it. Okay, we're going to change it by completing the square, and here's step number 3. To complete the square, we take half of this middle coefficient. And I like to think of it as half of it. Don't think divide by 2. Because if this is a fraction, How do you divide a fraction by 2? That makes it a little more difficult. Just think I'm going to take half of whatever that coefficient is. So what is half of positive 4? Positive 2. Now I'm going to write a positive 2 right here, and I'm going to circle it. I'm going to circle it because I'm going to come back and use that in just a second. I take that number and I square it. What do you get when you square positive 2? 4. Okay, so I'm going to write a 4 right here. Now, at this point right here, have I changed the problem? Yes, I have. I've changed the problem, so somehow we need to compensate for that. Now, this is the part that messes people up. They can't remember how to compensate. So, in my class, if you were in my class for 1010, I said, draw a line from here to here. I added 4 inside the parentheses, but there's a 2 outside the parentheses. So what did I really add? I added 8. So I'm going to write plus 8 up here. Whatever this number is up here, I write the opposite of that number here. So I'm going to write subtract 8. So inside the parentheses was a 4. Outside was a 2. So in reality, I really added 8. So if I subtract 8 from each side, those two things will cancel each other out, and then I really haven't changed anything. Or whatever I've changed, I've compensated for. Does that make sense? Okay, so here's what we've got. I'm going to change back to red. I've got f of x equals, this is going to be 2 x squared plus 4x plus 4, and this is going to be a minus 3. Is everybody okay with that? Okay, now I'm showing a little bit too much work. I'm showing all of the steps, because now we're to step number 5. It says factor and simplify the equation to put it in vertex form. This right here, what I've made is a completed square. I've made a perfect trinomial square. So if I write down what this is in vertex form, I've got a 2 outside. This is a perfect square of that variable right there, the x, and that number that I circled, positive 2. If you take x plus 2 and square that, you get x squared plus 4x plus 4, and outside is a 3. And once you have that, it's now in vertex form. So we can now look at this and we can say, hey, that moved it left 2. That moved it down 3. And this, okay, it's a vertical stretch by a factor of 2. Twice as, or I'll write it this way, twice as tall. Okay. So now we can graph it. This is the type of thing that you actually had to graph on the last test. Okay, are there any questions to there? Okay, let's talk about what you can tell just by looking at it. What you can tell is it's a parabola. You can also tell that it's been vertically stretched by a factor of 2, so the graph is twice as steep as it used to be. And you can also tell because the 2 is positive, which way does it open? Opens up. Okay? Now, with all of this in graph-friendly form, let's see, the vertex is going to be left 2 and down 3, so we're going to be right here. I'd normally go over 1 and up 1. I'm going to go over 1 and up 2. So I'd do the same thing on both sides. I normally go over 2 from the vertex and up 4. I'm going to go up 8, so that's going to put me right here and right here. So this is 0, 5. This is negative 1, negative 1. This is negative 2, negative 3. This one would be negative 3, negative 1. Look at how those y coordinates are the same here. And this one is, let's see, this is going to be negative 4, comma 5. And there's our graph. Put arrows on the end, label a couple points, 3, maybe 5, at least 3 points, so people can tell you know what you're doing, but that's it. So the only thing that we've gone over that's new so far is how to complete the square. And that's just a reminder of stuff that you learned probably about a month and a half ago in 1010. Okay. Any questions there? Okay. So let's talk about what we've got if we have something in vertex form. The vertex is always at, not for this, not when it's in vertex form like this, HK. It's always at HK. Okay. When we graphed these before, we didn't make a big deal about the axis of symmetry, but it does have an axis of symmetry. It runs right down the middle of it, right through the vertex. And since it's always a vertical line when we're dealing with things like this, it's going to be x equals whatever the x coordinate of the vertex is. So it's going to be x equals h. How do we tell whether it opens up or down? Okay. If a is greater than 0, in other words, if it's positive, it opens up. It'll open down if a is less than 0, or in other words, if a is negative. Okay, this part's a little bit counterintuitive. If it opens up, will it have a max or a min? If it opens up, it's got a very bottom. That seems kind of weird. If it opens up, you'd think max, but it has a min. Okay, and if it opens down, it'll have a max. Okay, parts of the graph that go up, so this part right here where it's going up, what name do we give a function? How do we describe a function that's going up? Not always positive, because this is going up, but the values are negative. Okay, there it is. It's increasing. Okay, so we're going to add to our analysis of what a quadratic function looks like and all that sort of thing by talking about where it's increasing, where it's decreasing, and all that sort of stuff. You guys doing okay over there? Josh and Colin? We're getting this? Good. Okay, parts of the graph that are going down. Whoops, I need to change that. I got to get rid of that word. I got an extra word. Parts that are going down are decreasing. Okay? All right. Any questions? Okay, because we're going to add a little bit more now. Okay, but I think you've seen most of this. Okay, it's really important when you graph something. Most of the time we're interested in some key points. Like we'd always want to know on a parabola where the vertex is. We usually want to know where a graph crosses the y-axis and where it crosses the x-axis. So we're really interested in finding the intercepts. Okay, and if you want to find intercepts, you always can just make a little xy table, plug in a 0 for x, that'll give you the y-intercept, and plug in a 0 for y, that'll produce the x-intercept, or intercepts. Now, with a parabola, there are a couple things that can happen, so I want you to take a look. Okay, on a lot of the graphs that we have, they'll do something like this. 2 x-intercepts, 1 y-intercept. It could do something like this. This happens occasionally, although this is somewhat rare. It could come down here, touch here, and go back up. It's got 1 x-intercept and 1 y-intercept. Okay, what's the final case? No x-intercepts. It could do something like this. Okay, that could be our parabola. Okay, it's got a y-intercept, but it never comes down and crosses the x-axis. It doesn't even touch the x-axis. So this would be 2 x-intercepts. This would be 1 x-intercept, and this would be no x-intercepts. By the way, look at each one of these. How many y-intercepts are there? 1 in every single case. If you're dealing with a parabola, it will always cross the y-axis. It'll only cross in one place. Why can't it cross the y-axis in 2 places? Because then it wouldn't be a function, because the y-axis is a vertical line. Okay? Now, if you get stuck in trying to find where the x-intercepts are, you can always find where it crosses the x-axis by solving it using the quadratic formula. So, would you write down the quadratic formula right there? Don't look at your neighbor's paper. Just write down the quadratic formula. No humming or singing unless it's in your head. Goose, quadratic formula.
Negative b plus minus square root all
Okay, that's it. If you don't have that memorized, you absolutely have to have that memorized. That'll come up a ton in this class. It'll come up in 1050. It'll come up on the ACT. It'll come up in nearly every single math class you take from here on out. Okay, so make sure you've got it memorized. I usually caution people, most people get the negative b part right. Most people get the 2a part. They even square things correctly. Here's where they make mistakes. They make mistakes on the 4ac part. It's a minus 4ac part. And what they usually do is they usually get the sign wrong. Okay, so we'll practice that just a little bit. Okay, any questions before we flip the page over? All look pretty familiar? Okay, let's take a look at this one. You did problems like this when you were in 1010, but we're going to add a little bit. So here's what it says. It says graph this, determine whether the graph opens up or down, find its vertex, axis of symmetry, x-intercepts, y-intercepts, and determine the domain and range. Then determine where the function is increasing and decreasing, and the word I want to underline here is where. Okay, now before we even do the problem, don't start working yet. If I ask you a question and I say, where does something happen, am I talking about an x-coordinate or a y-coordinate? X-coordinate. We're looking for x-coordinates there, okay? All right, so the first thing we want to do is we want to put this in vertex form so we can tell what it looks like. Now, we can't tell something by looking at it just here. Does it open up or down? Okay, so this opens up. Stretched or shrunk? Regular shape. Nothing weird happened to it. No transformation as far as the shape of it. Okay. Now we're gonna practice completing the square because you do need to know how to do this. I am going to show you a different way to figure out how to graph it, but I'll do that on the next page. You've got to know how to complete the square. We're going to do some stuff later in this class where if you don't know how to complete the square on something as easy as this, you're in big trouble when we get to that. Okay. So please be patient. We'll do a couple this way. So the first thing we do is we get the variable terms by itself, leave the 9 off on the end. This starts off with a 1. I can't complete the square unless it is a 1, but I don't have to factor anything out. So steps 1 and 2 we're done right now. Now we take half the middle coefficient. What is that? -3. I'm going to circle that. I'm going to square it and add it inside the parentheses. Now, technically, what number is outside? A 1. When I multiply these together, I get a positive 9. So I did add 9 inside the parentheses. In fact, even when I multiply it by the number outside, all I did was add 9. It's not like the one that I did up here, where I added 4 inside the parentheses, and the net effect was I really added 8. Okay? So this one's a pretty easy one. It's nice when they start off with a 1 in front. Okay? So how do I compensate for adding 9? I'm going to subtract 9. Whatever this number is here, I'm going to write a minus whatever that is here. So if this is a positive 9, I write minus 9. If this is a negative 10, what do I write? Plus 10. Okay? So now this is f of x equals a perfect square with that variable and that number right there, quantity squared. And what do these two add up to? 0. So it's really just this. Which we've graphed, yeah.
So is the first step even necessary then, because it was a perfect square to begin with?
If you see that immediately, if you can say, hey, I recognize that, that's a perfect square, then no, you don't have to do that, okay? But this is one of the rare cases where it is a perfect square already, so we just went through this for practice, okay? Just to make sure everybody understands the process, okay? Didn't hurt us at all.
Yeah.
Okay. Any questions? Okay. What happened to this parabola? How do we graph it? Move to the right 3. So 1, 2, 3, standard shape. Okay, now I'm going to graph just, let's see. If I start graphing this, I know I've got the x-intercept right. Okay, the x-intercept is 3, 0. The axis of symmetry is x equals 3. Okay, it also asks, so we found the vertex, we found the axis of symmetry, it wants the y-intercept and the x-intercept. Okay, how do we find the y-intercept? Make x equal to 0, right, Shane? Absolutely. Okay, so we can plug a 0 in here, or, let me show you a little trick. The easiest place to find the y-intercept is, look at this original thing right here. If I plug a 0 here and a 0 here, the only thing left is 9. This crosses at 9, so I'm going to put a dot right there. Okay? So 0, 9 is the y-intercept. So the graph looks something like this. So if this were a test question, I graphed this, I labeled the y-intercept, I labeled the vertex, and let's say I do one more point. That would be 4, 1. I've got the axis of symmetry. Would everybody be convinced that we know exactly what we're doing here? I think so. I think that's probably enough. Okay, any questions? Okay, let's look at A. Determine whether it opens up or down, got that. Found the vertex, axis of symmetry, y-intercept, x-intercepts, good. Domain and range, so let's figure out the domain. You can plug in anything you want. There's no division, there's no even roots, there's no logarithms, so we're going to be able to plug in anything you want. So that's going to be all reals are negative infinity to infinity. And then let's write down the range. Okay, it's going to be 0 to infinity. Always round around infinity. What about the 0 in this particular case? It's going to be square, because it does actually come down here, and it actually touches the x-axis right there. Okay? Comes down and bounces off there. Any questions? Okay, so we've got, this is part B here. Let me switch colors again, and this is going to be C. We want to know where it's increasing, and we want to know where it's decreasing. So go ahead and write down where it's increasing, and write down where decreasing. Increasing and decreasing. It's coming down all the way here, and then it starts going up. So it's going up right here. It's increasing on what interval? 3 to infinity. Because remember, we're talking about where. We're talking about the x-coordinates. From 3 forward, from 3 to infinity, it's going up. And from negative infinity to 3, it's going down. So there's where it's increasing, there's where it's decreasing. John?
Does it ever touch 3? I thought it was square around 3.
You could do either. Okay, if you wanted to put square brackets around it, you could. Okay, you could get mathematicians that will argue whether or not you ought to put square around. So you could do either one. I'd take either on a test. Okay. Any questions? Okay, one more by completing the square, and then I'll show you the other way to do it. Okay, that does have a negative on it. That is a -2, so you got to be a little bit careful. We can look at this and we can figure out a couple things before we even get started. So I realize you're familiar with this, but everybody watch, please. This is the way I'd like you to do it. If you have to determine whether the graph opens up or down, that's easy to tell right here. Opens down, because that's negative, right? Vertex, can't really tell by looking. Axis of symmetry, can't really tell by looking. Y-intercept. Every parabola has one. What is it? It's going to be 1. Okay? Those are the things that are easy to tell from right here. You can tell it opens down. You can tell it's been vertically stretched. And you can tell what the y-intercept is. The y-intercept is 0, 1. So we already know a point on the graph. We know we're looking for a parabola that opens down, and it's got to go through 0, 1. Now, let's put this in vertex form so we can figure out the rest of this. So this is f of x equals, okay, watch please. I would do -2 x squared. This is going to be -1/2 x, and this is going to be +1. Now take a good look at this. I picked this problem for a reason. It's got a negative in it, and it's got a fraction in it. Have I changed anything? Nope, I just changed the way it looked. I kind of ignored the 1 for a second, and I said, all right, I'm going to factor out a -2. So if I pull out a -2, I'm left with x squared. If I pull a negative out of a positive, that makes it negative. And if I divide a 1 by 2, I get a 1/2. So this is the same thing, it just looks a little bit different. Any questions? Okay, here's where it gets interesting. Half the middle coefficient. Half the middle coefficient. What is a half of a half? It's 1/4, right? So this is -1/4. Now, I'm going to circle this because I'm going to use this again in just a second. I'm going to square that. Now, I know you don't like fractions, but squaring fractions is easy because we've got this little property that says if you're going to square this, just square the top and square the bottom. Square the top, you get 1. Square the bottom, you get 16. And it would be positive because when you square a negative, you get a positive. Okay, now, what did I say you do once you put this number in here? Okay, draw this line. Okay, do me a favor. It takes you half a second to draw the line, but it just reminds you, hey, I've got to distribute. So if I multiply negative 2 times positive 1/16, I get this. Negative 2 times 1/16. Now, don't multiply these and get negative 2/16. How about we cancel this? That's a 1. Cancel that. That's an 8. So the answer is negative 1/8. So what I really did here is I really subtracted an 8. How do you compensate on the same side for subtracting an 8? Yeah. If this is a negative 1/8, you add 1/8. Fractions, not our favorite, but this is not that difficult a problem if you think about each one of the steps separately. Okay? Any questions? Yeah. Because 2 over 1 times 1 over 16 would be 2/16. You can reduce that, or you can cancel here. Cross cancellation. Okay? 2/16 reduces to 1/8. Is that all right? Okay. So let's clean this up and make it look right. So this is f of x equals negative 2 on the outside. You can go ahead and write a perfect square here. It's a perfect square of that variable, and what number goes right here? Negative 1/4. That's why you circle this, because you're going to use it again in just a second, and then all we have to do is fill in this number right here. 1 plus an 8. That's 8/8 plus 1/8, so that's going to be 9/8. That's 1 and an 8. So here's the vertex. Vertex is 1/4, comma, 9/8. What's the axis of symmetry? It's always x equals the x coordinate of the vertex, so it's x equals 1/4. Okay? Now, before you get too carried away and start graphing this, you'll notice that I didn't put any tick marks here. Okay, let's think about where this is. This is 0, 1, so this would be up 1 on the y-axis. And this is at 1/4, comma, 1 and an 8. So we probably ought to make this a pretty big graph. So I'm going to do this. Okay? That's positive 1 and that's positive 1, so here's 1 and here's negative 1. If I make that pretty big, it'll be easier to label. So I need to be at 1/4, so there's about a 1/4, and 1 and an 8. We're about right there. So that point right there is the vertex. There's 1/4, comma, 9/8. There's the vertex. Here's our axis of symmetry. Here's our y-intercept. Any questions? So we'd have another point right over here. And the graph is going to look something like this. Any questions? The domain and range, those are pretty easy, aren't they? What's the domain on any quadratic function? All reals, negative infinity to infinity. On this one, what's our range? What are our y values that we get out? Start way down here, negative infinity, all the way up to 9/8. All the way up to 9/8. Remember, we're talking about y values. That's why we use the y coordinate of the vertex. Okay? And then let's talk about increasing and decreasing. It's increasing over here and then decreasing over here. So it's increasing from, remember it's a where, so these are x coordinates, from negative infinity all the way to negative infinity to 1/4. Round or square around the 1/4, I don't care. Okay, and then it's decreasing from 1/4 to infinity. Any questions? Okay, we're not done. The last thing sometimes is the biggest pain in the butt to get. Got increasing and decreasing, got domain and range, up, down, vertex, axis of symmetry, y-intercept. What didn't we get? We didn't get the x-intercept, okay? And there are two of them. There's one here and there's one here. So we've got to figure out what those are. Okay, now, if you can factor this, that would be great. That would be a nice thing to do, a nice way to find the answer, okay? If you can't, you need to use the quadratic formula, okay? Or there's one more thing you can do. I like using the quadratic formula, so let's do that, okay? So here's the quadratic formula. This is going to be x equals negative b, so that's going to be negative 1 plus or minus 1 squared, so that's a 1, and then minus 4 times a times c. Now, I always write this 4ac stuff out, and then the bottom's going to be 2 times a, so that's going to be a negative 4. What's a? A is negative 2. And c is 1. Okay, so the first thing I would do is I would figure out, look, this is a 1 minus 4 times negative 2. Is this going to be am I going to be adding to 1 or subtracting from 1? I'm going to be adding. So I'm going to add 1. So, or excuse me, add 8. That's going to be square root of 9. Negative 1 plus or minus square root of 9 over negative 4. Any questions there? Keep going, right? Negative 1 plus or minus, what is the square root of 9? 3 over negative 4. Okay, now, if it's this simple, sometimes it works out with radicals. You've seen those before. But if it's this simple, let's write down the two answers. One of them is negative 1 plus 3 over negative 4. The other one is negative 1 minus 3 over negative 4. So this is going to be, well, let's see. That's going to be 2 over negative 4, so that's going to be negative 1/2. That's one of them. That's this one right here. You can see it. This has got to be negative 1/2 comma 0. And this one is negative 4 over negative 4, so that's going to be 1. Oddly enough, this one crosses at 1. So we should I'll erase that guy right there. And this one crosses at 1 comma 0. Okay? So we've got everything labeled there. This is quite a bit more in depth than what you did in 1010. Okay, sometimes they call this analyzing the quadratic. You're writing down everything about it. What's the vertex? What's the axis of symmetry? All the intercepts, x and y intercepts. Okay, where is it increasing? Where is it decreasing? What's the domain and the range? You're basically describing everything about it. Okay, any questions? Okay. Let's go back and find the intercepts on example 1. So let's come back here. Let's find out where it crosses. Does that factor? Let's see, we could check. Multiply the 2 and the 5 together. That's a positive 10. Can you find two numbers that multiply to be positive 10 that combine to be 8? Nope. So you got to use the quadratic formula. So let's go ahead and do that on this one. This is going to be negative 8 plus or minus. If you want to write 64, that's fine. There's the AC stuff. And this is 4. 2a would be 4. This is going to be negative 4 times a is 2 and c is 5. So this is going to be 64. Am I going to be adding something to 64 or subtracting something from 64? We're going to be subtracting. What are we going to be subtracting? 40. Subtract 40. So this is negative 8 plus or minus the square root of 24 over 4. Okay, are there any questions to there? Shane, this is the tedious stuff, right? This is the stuff that's a pain in the butt? Yeah. Okay, but you've got this down, right? Oh, yeah. Absolutely. Okay. What do we do with the 24, Shane? You do. And how do you simplify the square root of 24?
Well, first you make a little factor tree.
Okay, so it's going to be 2 times 2 times 2 times 3, right? 8 times 3.
Yeah. Well, the pair of 2's.
Pair of 2's here, so this is going to be negative 8 plus or minus 2 radical 6 stuck underneath with a 4. And then does anybody see anything we can do here? Sort of. Technically, can I just say, hey, I'm going to cancel the 2 and the 4, or I'm going to cancel the 8 and the 4?
No.
No, really what you do is you have to cancel factors. You don't cancel terms. So really what I had to do is I had to pull out a 2. You're alrighty, getting temperamental. Pull out a 2. Good at sticking around. You're left with a -4 plus or minus radical 6. This would be over 4. Then you can cancel those. So I cancel these 2. There's a 2 left. So this is going to be, oops, let's see. Yeah, we're okay with that. -4 plus or minus radical 6 over 2. So the two x-intercepts, one of them is -4 plus radical 6 over 2, and the other one is -4 minus radical 6 over 2. Guess which one is which? Which one do you think this one is? The left one or the right one? This one's going to be the right. Okay. Now, a cool thing that you can do, watch please, because this is going to help make sense of the next part. If I write this as two separate fractions, this would be -4 over 2 plus radical 6 over 2. That's -2 plus radical 6 over 2. -2 is the axis of symmetry, and then I go over radical 6 over 2 to get to this one right here. On this one, it's -2 minus radical 6 over 2. So you kind of start at that center line, the axis of symmetry, and we're going to go this way, radical 6 over 2 to get to that one, and this way, radical 6 over 2 to get to that one. Okay? So here's one x-intercept. Here's the other one. Okay? This is that one right there. This is that one right there. Okay? All right. So you're probably all aware that there is a little bit shorter way to do that. Okay, but you have to know how to complete the square. So as you're going through and doing the assignment, please do several of them by completing the square, because if you wait till the end of this semester to go back and relearn and remind yourself how to complete the square, we're going to be dealing with some things called conic sections, hyperbolas, parabola, ellipses, circles, stuff like that. And if you don't know how to complete the square now, it's going to be much harder to remember then, and completing the square is just a tiny part of those problems. Okay? All right, so there are two options for analyzing these parabolas. Okay, this is what we just did. Complete the square, write it in that quadratic form, in vertex form, graph the function and stages using transformations. Find the x-intercept, the y-intercept, and all that sort of stuff. But if you think about how the quadratic formula works, it's x equals -b plus or minus b squared minus 4ac all over 2a. I could put the 2a stuff here and the 2a stuff there. I could break it into two separate fractions. This part right here is the x-coordinate of the vertex. It is the axis of symmetry. Because remember, like we were looking at before, we had that center line and we went forward this much and back this much to get to the x-intercepts. That right there is the x-coordinate of the vertex. So you can tell whether it opens up or down, just like we were saying before, by just looking at it, figuring out what A is. You can figure out what the vertex is by doing -b over 2a. Now, most people can remember -b over 2a, but this part right here gives them fits. What does f of -b over 2a mean?
You plug in whatever -b over 2a is equal to.
Yeah, whatever you get for this. So let's say we do this process and we end up with a 2. How do we figure out the y-coordinate for the vertex? Plug in a 2. Plug 2 in. Plug 2 into the function, okay? That is also the axis of symmetry like I was talking about, okay? And then it says determine determine the y-intercept, or we already talked about that. It's just going to be whatever c is. And then you can tell whether it's got one intercept, two intercepts, or no x-intercepts by just figuring out that stuff underneath the square root. Yeah.
So do you plug the 2 into just -b over 2a, or do the whole?
to the whole quadratic. This was just an example, okay? So if this were if we came up with an answer of 2, we'd put a 2 here and a 2 here. Okay, I'll do one like this in just a second, okay? So this is a shortcut only if you understand how it works. If you don't understand how it works, stick with the other, okay? All right, so let's do one like that, okay? So it says use either method above. So here's what we're going to do. We're going to look at this, and does this open up or down?
Up.
Opens up. Has it been stretched or shrunk? Okay, so regular shape. Okay, Y-intercept is easy to find. What's the Y-intercept on this one? It's 0. There's no constant there. So I get 0, 0. Okay, crosses the y-axis there. Okay, the next thing we're going to do is we're going to find the vertex. So we're going to do negative b over 2a. So in this particular case, negative b gives me a positive 4. 2a gives me a 2. So what is the x-coordinate of the vertex? It's going to be a 2. So let me do this. That's going to be a 2, right? Okay. Wow. Works out to be what we thought it was going to be. So then we're going to plug this in here. So let's figure out what f of 2 is. So this is going to be 2 squared minus 4 times 2. 4 minus 8. So that's going to be negative 4. That is the vertex. If that's the vertex, what's the axis of symmetry? X equals 2. Okay, so now we can come over here and let's start graphing this. The vertex is 2, negative 4. 2, negative 4 is right there. The axis of symmetry is x equals 2. The y-intercept we found right here. So the y-intercept is 0, 0, so let's mark that 0, 0. Well, if you've got this point 2, negative 4, and you've got this point 0, 0, wouldn't there be a point symmetric over here? Right there. So the graph has got to go like this. And again, usually we're going to want to label the intercepts, and at least 3 points total. So this one here would be 4, 0. Okay. And it just says graph using either method. We could figure out where it's decreasing, where it's increasing. We could figure out the domain and range and all that sort of stuff. Okay, any questions? Okay, 2 more things and then we're done. If you were going to solve for when this equals 0, so if we plug in a 0 for y, or plug in a 0 for the function value, the easiest way to solve this quadratic is by factoring. So this factors to x and x minus 4. So what's the solution or the x-intercept that comes from there? Hello? 0. And what's the x-intercept that comes from here? 4. That's the easiest way to find the x-intercepts, is if it factors. If it doesn't factor, you have to use the quadratic formula. Now, I don't want you to write this down, but I do want you to watch. Okay? There's A, there's B, and C is 0. So watch what happens if I use the quadratic formula. That's going to be 4 plus or minus 16 minus 4 times A, which is 1, and C is 0, all over 2A. So this is going to be 4 plus or minus the square root of 16 over 2. So that's going to be 4 plus or minus 4 over 2, which is either 4 plus 4 over 2 or 4 minus 4 over 2. What's this one? Okay, this one's going to be 4, this one's going to be 0. Or, okay, watch, bear with me, you don't have to write this down, I just want you to think about this. If I took this right here and wrote it this way, 4 over 2 plus or minus 4 over 2, I get 2 plus or minus 2. So this is the x-coordinate of the vertex. This is that axis of symmetry. And then this says, if you're on the x-axis, go this much to the right or to the left. So if I go 1, 2 over here, that's one x-intercept. If I go 1, 2 over here, that's another x-intercept. Does that make sense? Okay. Let me save this real quick. And then I just want to show you what I'd like you to do. Okay. We have covered all of the ideas in this section except for we're going to do some modeling problems. So there are some story problems. So they're like, they give you a certain amount of fencing and then they want you to close it in. So we've got a few problems like that, and then we've got some problems about revenue. Now, the reason we have to cover these is these will show up on the final exam in 1050. So when you take 1050, you can almost guarantee that there will be a problem like this. So we're going to get familiar with those. So what I'd like you to do today is go home and get started on this. The story problems don't start until about right there. So see if you can get all of these done. Come tomorrow with that all figured out. We'll take a couple questions and then we'll work on the story problems. Okay? All right. You're done a little bit early. Have a great day.